Hey guys, so what I'm going to do is I'm going to have a little look at the question 3 from 2019 mock papers, which is the circle question, which takes in a little bit of trigonometry, a bit of coordinate geometry as well. So it says that the circle K has a centre of 4, 0, and it cuts the y-axis at 0, 3. So my centre is here, which is 4 and 0, and cuts the y-axis at 0, 3. Now, first thing you're asked to do is find the radius. The radius is actually the length of this line here, from here to here. So remember, the radius starts at the centre and goes to the edge. So we can use the distance formula from coordinate geometry. So find the distance between these 2 points to figure out the radius. So if this is 0, 3, and this is 4 and 0, I can go x1, y1, x2, y2, and I can use my distance formula, which says x2 minus x1, so 4 minus 0 all to be squared, plus y2 minus y1, 0 minus 3 all to be squared. And when I put that into my calculator, I get the square root of 25, and that gives me 5. So I know that 5 is the length of my radius. So the distance of the line from this point to this point is 5 units. It's now asking me for the equation of k. So, important thing to note that the equation, so we don't have a centre 0, 0. So we have to use, when we're using the equation of the circle here, the formula x minus h all to be squared plus y minus k all to be squared is equal to r squared. And h and k are just our points, so at the centre. So it's 4 and 0 there. So we're going to write 4 and 0 here. So that's h and that's k, with r being 5. So just sub them in. So we're going to have x minus h, which in this case is 4 squared, plus y minus k, which in this case is 0 squared. It's all equal to r squared, which is 5 squared. We don't have to do any simplifying now. The equation of the circle is always given in this form here. So x minus h plus y minus k is equal to r squared. So we sub in 4, 0, and 5. So now we're going to move on to something slightly more difficult. So it's moving into your coordinate geometry and a little bit of algebra. So over here I'm just going to write down the important things. So 4 and 0 is my centre point, h, k, which is C. And another important one is 0, 3. And my radius is 5, so I might need this information a little bit later on, so I'm just going to put it to the side there, and I'm going to get rid of this. So, next one says, the circle cuts the positive x-axis at the point B, find the coordinates of B. So look in here, the circle cuts the positive x-axis, so it cuts here at this point B. So it's asking us to find the coordinates of that point B. So there's loads of different ways of doing this, but what I would say the easiest way to do this is, I know that 4 and 0 is my point here, and I know the length of this line is 5 because I know the radius. So when we hit the x-axis here, right, y is going to be 0. Remember that? So we're not going up or down on the y-axis. So I am going to move this point along 5 more units in the x. So realistically, if I have 4 and 0, and I'm moving across 5 in the x, I'm going to add 5 here, so I get 9 and 0. And there's a longer algebraic way of doing that out, but have a little think about it. You have this point centered here, and you're moving straight across to this point B. It's 5 units there, you're moving across. So just add 5 to the 4, gives you 9. You're not going up or down and changing the y value, so it's 9 and 0. Again, there is an alternative method, but it is a much longer method. It involves subbing back into the equation of the circle, where we can just read it straight off here. Part C, use trigonometry to find a measure of the obtuse angle ACB shown in the diagram. Give your answer correct to the nearest degree. So going back to trigonometry here, which you haven't done in a while. So we're asked to find the measure of this angle here, ACB. So first thing I'm going to do is I'm going to redraw this out, but I'm not going to draw in the circle. I'm just going to draw in the triangle part here. So we have, in this case, something that looks like this. We're looking for this angle X here, and our point C here, which is 4 and 0. Our point B here, which we worked out is 9 and 0. And our point A here, which is 0, 3. What other information do we know? Well, we know the lengths of the sides, don't we? So we worked out all the lengths of the sides. So what we can do is we can actually start subbing in for some of these. So I know here that this is going to be 5. And I know this is going to be 5. So I've got two sides. If I get a third side here, to figure out this angle, I can use my cosine rule. Now you might not remember using the cosine rule, but I can use the cosine rule if I have a third side there. So what I'm going to do is I'm going to find the distance between here and here using the distance formula. So I'm going to have 0, 3, and I have 9 and 0. So that is x1, y1, x2, y2. And I'm going to put it into the distance formula, which is 9 minus 0 all to be squared, plus 3 minus 0 all to be squared. And that gives me the square root of 90. So I now know that this here is the square root of 90. And what I can do with those three pieces of information here and this is I can sub them into the cosine formula. So the cosine rule lets me find a missing angle if I have the three sides. And it says that a squared is equal to b squared plus c squared minus 2bc times the cosine of a. And the important thing that we need to note here is that we can label these any way we want. So I'm going to label this A because the one across from it is going to be my angle A, which I'm looking for. So we're doing opposites. So if that's A, this is my angle A, so that's going to go there. Which means that I write square root of 90 here, squared. The square root of 90 squared is equal to B, which is 5 squared, plus C, which is 5 squared, minus 2 times 5 by 5 by the cosine of A, and we don't know what that is, so I'm going to leave that as the cosine of A. And what we can do then is we start simplifying it down. Square root of 90 squared gives me 90. That can only be 25 plus 25, 5 squared and 5 squared, minus 2 by 5 by 5. 2 by 5 is 10, 10 by 5 is 50 times the cosine of A. Now remember, that 50 is attached to the cosine of A here. Let's bring both of these over. So it's going to be 90 minus 25 minus 25, which gives me 40. Is all equal to minus 50 times the cosine of A. Now to get the cosine of A by itself, I'm going to divide across by minus 50. So I'm going to divide this by minus 50. So when I do that, I'm going to have 40 over minus 50 like that is all equal to the cosine of A. So what I've done there is I've taken my minus 50 and I've brought it across. So it's going to be 40 all over minus 50. And I can put that straight into my calculator. So I'm going to write cosine to minus 1 minus 40 over 50. And it's going to be an angle of 143.1 degrees. Find the area of the circle enclosed in the first quadrant. So the area of the circle enclosed in the first quadrant. So this here, a little bit more tricky, and this takes in a little bit of area and volume.